So, if you remember, you see it on the board here, we were doing all this kind of graphing the other day. These problems are the exact opposite of graphing. So you are given, I'm going to do letter B, you are given the graph. And your job is to come up with the equation. Now, one thing that we need to reiterate, because I think some of you were a little confused by it before, is that when you are building your equation, you're going to have some factors. And the factors come only from the points on the x-axis. So I know there's another point down here. We're going to deal with that, but that is not a parentheses. So what would the parentheses be? There's going to be 3 of them. What will they be? X plus 4, X plus 2, X minus 3. Now I'm going to look carefully before I go any farther. Should there be any squares on any of these parentheses? Well, let's look. Does this bounce off? No. Does that bounce off? No. Does that bounce off? Nope. So if nothing's bouncing off, then there won't be any squares, right? Okay, so now I'm ready to go. I need to figure out what that number is. That is the only thing missing in my equation. This is going to be my equation, except I need to know what that number is. How do I find what that number is? I do just what I did on my quiz. I plug in this extra point. Remember, it's only the ones on the x-axis that make your factors. That extra point gets plugged in, 0 for all of the x's, and -3 for the y. That's x, y. So all the x's are zeros, y is -3. And then just do the math. So 0 plus 4, 0 plus 2, 0 minus 3. These are all multiplied. These are factors. So it's all multiplied together. So what's 4 times 2 times -3? -24. -24. So -3 equals -24n. -24 times n. So dividing, it looks like n is what?
3/24.
Which is
8.
1/8. And then your answer, kids, it's as simple as this. Your answer is all that stuff, but instead of an n here, it's a 1/8. That is the answer to the problem. That's all there is to it. Truly, it is not too tough. All right, let's look at the next picture. Remember, your parentheses, when you build your equation, your parentheses come only from the dots on the x-axis. Okay, this one's got a tricky one in there. Where are the dots on the x-axis this time? Where are my factors? X plus 2. X plus 0, which if you want, you can put x plus 0, or you can just put plain x. If you are at 0, it's x plus 0 or x minus 0, it doesn't matter. Or you can just put plain x, whatever works for you. It makes me no difference at all. And then the other one is x minus 3. Now, let's trace over our curve. What happens right here? So that factor, that parentheses, is going to have to be squared. Would you agree with that?
Mm-hmm.
What happens here at the x? It bounces, so it's going to have a squared. And what about at the 3?
Nothing.
No squared. No squared, no bouncing. So stop right there. This is our last one of these examples. Oh no, I guess there's one more. Anybody have a question about so far? Again, if this one is bothering you, think of it as x plus 0, if you'd rather.
Could you just put parentheses around it?
Yep. Okay, now we gotta find n. How are we gonna find n?
Plug the 2 in.
Plug the 0.22 in, so it doesn't really matter, but this is y, so 2 equals n. We have 2 squared, 2 plus 2 squared, and 2 minus 3. And now we'll do the math. So 2 equals n times, all right, 2 squared is 4. 2 plus 2, 4, but squared is 16. And then 2 minus 3 is negative 1. So I have 2 equal to, all right, 4 times 16 times negative 1. Use the calculator if you need to. 4 times 16 times negative 1 is negative 64n. So then n will be 2 over negative 64, which reduces to 1 over 32 negative. So your answer is negative 1/32 x squared, x plus 2 squared, x minus 3. Okay. Now, the next one is the same thing, only they didn't draw a picture. If they don't draw a picture, what do you have to assume? What do you not know? If there's no picture in front of you, what do you not know? Whether it bounces or not? So if they don't give you a picture, then you're just going to assume that it does not bounce. So you're going to assume if the x-intercepts are at negative 1, 2, and 4, you're just going to assume that it goes through once. So what will our factors be? 3 of them, because there's 3 zeros, 3 x-intercepts, 3 dots. What will they be? X
Plus 1.
plus 1
X minus 2.
minus 2
X minus 1.
minus 4. You don't have a picture, so that's it. We're done. We just got to figure out what this number is. Did they give us a contains point? Did they give us an extra point? Yes. Y is 10 and x is 1. So 10 goes into my equation for y, and all of the x's are 1. Then I do the math. 1 plus 1, 1 minus 2, 1 minus 4. Yeah, if you need a calculator, use it. What's 2 times negative 1 times negative 3? 6n. So it looks like my n is going to be 10 over 6, which is 5 over 3. Okay? Now we're gonna sketch again, if you look at number 3. But what's the difference with this problem? Why does this one look different than the ones on the other side here that we did the other day? What's different about this one? What? Well, yeah. What did the other ones look like? On this page right here that we did, we whizzed through that. Those were so easy. But they were all factored, right? Didn't they all look like this? If they look like that, then it's easy to graph. You just put your dots on there and start connecting them. What in the world are we going to do then to graph this one? We're going to have to factor it. So you're going to have to make it look like this. Okay, well this one's not bad, because if you look at it, can you see that it's going to factor by grouping? If I do the first 2 terms, what can I take out of the first 2?
X squared.
X squared. So I'm going to take out an x squared. What will I have left if I, right here, if I take out an x squared? X minus 4. Perfect. Now, you're probably looking at these 2 and thinking, there's really nothing I can take out. But you can always take out a 1. And this time, I'll take out a -1. So you can always take out a 1, remember. I'll take negative because that's negative right there. So if I pull out a -1, that's going to become x minus 4. And that is beautiful. Because now I have my common factor, my x minus 4. And then I also have left over x squared minus 1. How many millions of times have you and I together in this class already, how many times have we seen something like this? A lot. What is x squared minus 1?
Difference of squares.
It's called the difference of squares. It's x plus 1, x minus 1. Now we aren't done, but we've done the first step. Can we now graph it? Now that it looks like that, can we graph it? Yes. So we will put x-intercepts at 4, 1, and -1. And then, this is an x cubed. How do x cubes always start? Down and end up. Yep, that's going to look like that. Is anything bouncing or anything in this problem? No. So we're just connecting the dots. So we come up from the bottom, connect, connect, and finish. There it is. Who would have thought that it's that easy? Okay, so here we go. Next one. Are we going to have to do something very similar for problem B?
Yes.
All right, so factor by grouping. What can we take out?
X squared.
X squared again, and we're left with x plus 3. What can we take out here?
-4.
-4. I would always, if that's a minus, I would always take out the negative. So minus 4x plus 3 again. Oh my, this is so wonderful. Look what we have this time, guys.
Ooh.
X plus 2, x minus 2.
Yeah.
So everybody's caught up here? Everybody got it? So you know where your dots are? -3, -2, Do you know where to start?
Up.
Bottom left.
Down here? Because this is another x cubed. So we're gonna start down here. Are we bouncing at all, doing anything weird?
No.
Connect the dots. Wow. Last one we do today, one more. Shall we approach it the same way?
Yes.
So what can we take out of the first two?
2x squared.
2x squared. And what will we be left with?
X minus 1.
X minus 1? Make sure you can do that. Everybody doing that okay? Alright, what can we take out of the last two?
Negative 8.
Negative 8. Like I said, I would always take that negative out. So we're taking out negative 8, which leaves us with x minus. You took out the negative. So it's going to leave you with x minus 1. Thank goodness, because now they match. What about 2x squared minus 8? Can I do anything with that? Can I take out a 2? Okay. So I'm going to put the 2 out here in front. I'm taking a 2 out. And then if I take a 2 out of here, I'll be left with x squared minus 4, which is x plus 2, x minus 2. Now, see that 2 right there, that coefficient? It does not have an x attached to it. It is a plain 2. And because it's a plain 2, it doesn't get graphed. There are going to be 3 dots. The dots come from the x's, okay? So you can have whatever number you want here. It doesn't matter. It's just there. That's like your n in the problems we did earlier. So, where are your dots? Positive 1, I heard somebody say. Positive 2 and negative 2.
Yep.
Nothing is squared. This is another x cubed. So remember, it has to go through those points. So it has to go through, turn around, go through, turn around, and finish. Easy. Easy peasy. All right, I don't have it delineated in the notes, but 2-3 homework is now due. That's the end of 2-3. So 2-3 will be due on Monday. 2-3 will be due